Hello, welcome to 2.3 Transversals. This is our next video for our Unit 2. We're going to be talking about transversals, and to start off, we got to define what a transversal is. A transversal is a line that intersects two or more lines at different points. So in this case, we would say line T is the transversal as it goes and intersects line P and line K. All right. And the reason T is a transversal because it intersects two or more lines. In this case, it's intersecting line P and line K at these 2 points. All right, making it the transversal in this case. All right. What line is the transversal? Now we've got 4 lines here. We've got line A, line B, line C, and line D. Now we're looking for the line that is intersecting two or more other lines. Okay. Now in this diagram, right, and it's not these aren't extended. If we did have these lines extended, then there could be more than one solution. But just within our window here that we can look at, which line is the one that intersects two or more? Well, in this case, A is our transversal. Okay, because A intersects two or more, and they have to intersect two or more at different points. All right, because I would agree, line B and line D also intersect two or more. All right, but their point of intersection is common. All right, it's right here. We need to make sure that intersection point is at two different places, which is why A is the one that makes sense because we have an intersection point here and an intersection point over here. All right, so A would be the transversal intersecting B, D, and C. Name the transversals. Here's an example where there's multiple transversals. All right, now when we say that a line is a transversal, we have to say it's transversing through which two lines. So we could say, let's do all these lines. D is the transversal because it is transversing lines B and C, right, at these 2 points, right? We could say A is the transversal intersecting B and C at these 2 points. We could also say line B is the transversal because it intersects lines A and D at these 2 points. And lastly, we could say C is a transversal because it intersects lines A and D at these 2 points. Okay, so all 4 of these lines could be considered transversals, but we have to identify what lines they are going through and intersecting. When we have transversals, we're able to get more angle pairs and ways to describe the angles that are made from that transversal. All right, so we have a transversal here. A is our transversal. All right, so line A is our transversal. And we have these angles that are made up now because we got angles 1, 2, 3, 4, 5, 6, 7, 8. Now, one type of angle pair that's made, or types of angles that are made, are called interior angles. Interior angles are the angles that are between the two lines that are intersected by the transversal. Okay, so in this case, angle 3, 4, 5, and 6 are our interior angles. Okay, now one way that I like to describe this, and I think it helps some people, but if you're unsure what an interior angle is, okay, think about your transversal as a bridge, and the two lines that it intersects are like the banks of a river. All right, interior angles are the angles that are in the river. All right, again, the transversal is the bridge. Everything in between, okay, the two lines that the transversal is intersecting would be the river, and every point or every angle that lies in the river would be the interior angles. Okay. Again, you don't have to use that, but if it helps you out, please do so. Okay. So again, as we mentioned before, our interior angles are angles 3, 4, 5, and 6 in this case. All right, here's a different one. We got A goes horizontally here, and we got B and C. So A is the transversal with lines B and C. Our interior angles in this case are going to be inside. So we got 2, 3, 5, and 8 are our interior angles this time. Exterior angles. So we have our interior, the ones in the river. Exterior, the ones on the outside, the angles that are outside the two lines that are intersected by the transversal. So our intersection here is our transversal is K because it intersects H and J. The exterior angles are going to be the ones on the outside, angle 1, 2, 7, and 8. These are our exterior angles. Okay, 1, 2, 7, and 8. Now, in this case, we're back to that diagram we had before. A goes horizontally. So there's our river. Interior would be 2, 3, 5, and 8. Our exterior angles are going to be on the outside, on the bank, 1, 4, 6, and 7 are the exterior angles. Corresponding angles, okay? Two angles that lie on the same side of the transversal, one interior and one exterior angle, and they're non-adjacent. So when we have corresponding angles, we're going to talk about angles that appear at different intersection points, okay? They're going to be at different intersection points. So we have an intersection here, an intersection here. I think one way to talk about corresponding angles, all right, the way I like to remember them is they correspond to the same location from the intersection. So if I look at the intersection point right here, the top left angle to that intersection is there. That's 1. If I go to the other intersection point, top left is angle 5. 1 and 5 are corresponding angles. They're two angles that lie on the same side of the transversal, so they're above the transversal in this case. One interior and one exterior. 5 is the interior, 1 is the exterior, and they're non-adjacent. Okay, because 6, we could say 6 would work. It's on the same side. We have the interior 5, the exterior 6, but 6 and 5 are adjacent. All right, so that wouldn't fit. We need the non-adjacent one, which is why we have to look at the angles that are located at different intersection points. Okay, now we can do the same thing. We could say, all right, well, let's talk about the corresponding angle pairs that are up and to the right from our intersection. Well, that would be 2 and 6. So there's another pair of corresponding angles. Well, I could also do the bottom left pair, 4 and 8. 4 and 8 are corresponding angle pairs. And lastly, we could do the bottom right, 3 and 7. Okay? So when you have a transversal with those two intersection points, there's actually 4 pairs of corresponding angles. Okay? In this case, our transversal now goes up and down. So if I want to talk about an angle pair, again, I look at my intersection points. And if I want to do top left, up and left, up and left, that gives me an angle pair. 1 and 5 in this case are corresponding angles. Again, we could keep doing this with all these if we want to do, and it does, and these fit, okay? Because now instead of, we're not saying they're both above the transversal, we say they're both on the left side of the transversal, so they're on the same side, all right? They're on the same side. We have 1 interior, 5, 1 exterior, 1, all right? And they're non-adjacent. If we went to the top right, that'd be angle 2 and angle 6. Bottom left would be 3 and 7. And lastly, bottom right, 4 and 8. Okay, giving us our 4 pairs of corresponding angles. Now, most of the time, we're not talking about all 4 pairs. We're going to be talking about just one pair and some of the properties that they share because they're corresponding angles. Alternate interior angles, right? Alternate interior angles. A lot of times we'll abbreviate this and say AIA. Okay, they're alternate interior angles, and that's because there's going to be some special properties we talk about with these angles. So two interior angles that lie on opposite sides of the transversal, non-adjacent. Okay, so let's take one of our interior angles here. Let's say angle 3. Okay, we got angle 3 here. Well, I want to be two interior angles, so I know it's going to be an angle pair with one of these other 3, 4, 5, or 6. Lies on the opposite side of the transversal, so it's either now 4 or 6, because 3 is on the left, 4 and 6 are on the right. Non-adjacent, so it can't be 4, because 4 and 3 are adjacent, so it's got to be 6. Alternate interior angles. Okay, these are alternate interior angles, 3 and 6. Now there is another alternate interior angle pair. Okay, 4 and 5 are also alternate interior angles. And this is true in all transversal cases. There will be 2 pairs of alternate interior angles. Why? Because there's 4 alternate interior angles, and you can pair them up. So you get two go with one pair and 2 go with the other pair. In this case, with the horizontal line, we've got some alternate interior angles. We could say 2 and 8 are alternate interior angles. And we also have 5 and 3. Okay. Alternate exterior angles, same idea, except now we're talking about two exterior angles lying on opposite sides of a transversal and non-adjacent. So again, they can't be next to each other. So like even though 1 and 4 are exterior angles, they cannot be the alternate exterior because they're adjacent to one another. So if I say angle 1, I've got to go all the way over here to angle 7 to get the alternate exterior angle pair with 1. The other pair, just like with alternate interior angles, there's going to be 2 pairs of alternate exterior, 4 and 6. Okay, so we do get 2 pairs of alternate exterior angles with each transversal. Okay, name the alternate exterior angles. So this one's a little bit different view here, but same idea. We have our transversal, line A, intersects at this point and this point. Now the exterior angles are going to be 1 and 4 and 6 and 7. So if I say, all right, let's pick 4 as an exterior angle, the alternate exterior, I got to go to the other side of the transversal and then the other intersection point. 4 and 6 are an angle pair, alternate exterior angle pair, and 1 and 7 are an alternate exterior angle pair. Same side interior angles, okay? And I should have mentioned this before, but with the alternate exterior, we can abbreviate this AEA, right? And with our same side interior, you could do that with your same side interior angles as well, all right? So you are allowed to abbreviate those when we're talking about these different angle pairs made from the transversals. So same side interior, 2 interior angles that lie on the same side of the transversal, all right? So again, we've got a transversal A, intersection points are here and here. Interior angle, so if I say 2, the same side interior angle that is paired with that, we stay on the same side of the transversal. So we're above the transversal this way. We go to 5. 5 is the same side interior angle pair with 2. And then we also have 3 and 8 are another same side interior angle pair. Here we have a little different diagram. So we got a vertical line, same side interior angles. We would have 3 and 5. They're both on the left side in interior. And then we got 4 and 6 are the other same side interior angle pair. Here's where it gets a little difficult because now what we have here is a diagram where we've got four different transversals because I could say any one of these lines, A, B, C, or D, are transversals. Okay? So in order to determine all of these different angle pairs, right, whether they're corresponding, um, alternate interior angles, same side interior angles, alternate exterior angles. In order to determine those, we need to identify what our transversal is. Okay, we have to identify the transversal before we name that because, for instance, angle 3, right, or I should say angle 2. Angle 2 could be an exterior angle or an interior angle depending on which transversal. If C is the transversal, then it's an interior angle because it's between A and B. That's what C is intersecting A and B. But if I use A as the transversal, now angle 2 is an exterior angle because the intersection points are here and here. C and D are the lines, and 2 is outside the transversal intersections. Okay, so that's why we need to be careful when we are identifying those transversals because that's going to really determine our angle pairs. Okay, so this says using transversal A. All right, so using transversal A, my lines are really not good today. Let's see if I can actually just draw a line like this. Go with the purple. There we go. So using transversal A, what are a pair of corresponding angles? Now it's just asking for one corresponding angle. All right, just asking for one, but I need to identify here the fact that I've got transversal A, all right, and the two intersection points are located here and here, all right, and that's important. You identify that. My interior angles in this case are going to be 3, 4, 5, and 6. My exterior are going to be 1, 2, 7, and 8. But I need a pair of corresponding angles. Just one. It doesn't matter. There's four different pairs of corresponding. I'm just going to pick one. Angle 1, that's up and to the left from my intersection. Up and to the left is angle 5. So angle 1 and angle 5 would be a pair of corresponding angles. Now again, I could keep going with this. Up and right, angle 2 and angle 6 are a pair of corresponding angles. Angle 4 and angle 7. And lastly, 3 and 8. Okay? Now again, I don't know anything else about the relationship between these angles and the ones over here, right? Because I'm not focused on that. I'm only using transversal A and the 8 angles that are made from that transversal. I'm not, in this question, I'm not worrying about these other numbers. Okay? So that's really key here. You've got to pinpoint to the intersections that are relevant with the transversal that's given. Using transversal D, right? Using transversal D, what are a pair of alternate exterior angles? So D is here, right? My intersection points are located here and here. Alternate exterior. So we need to identify the exterior angles first. Well, if this is the transversal, 6, 8, 13, and 16 are inside. They're interior angles. So the exterior are going to be 5, 7, 14, and 15. What are the pair of alternate exterior? Let's pick 5. That's an exterior. And that's going to be paired with, I got to go on the other side, non-adjacent, 15. 5 and 15 are a pair of alternate exterior angles. The other pair we have here is 7 and 14. So there are two pairs, all right, of alternate exterior angles. But again, we had to identify the transversal first. Okay. If you need to, one thing that I like to do if I'm working on this, if I don't want to get confused by these other 8 angles that are up here, all right, let's see. I think there's some way. There's some way where well, it's not going to work this way, but I actually take my hand and I cover up the page. So let's say our transversal is C. Well, I could cover up D and just focus on these 8 angles. All right. Now I'd be doing it with my hand instead of this figure here, but same idea. Okay. Um, let's say I could probably do it with a box. Unfortunately, I think this box is going to be huge. Oh, because that was a square. I don't want a square. I want a rectangle. Let's try a rectangle. And then I'd have to fill it in. Fill color. There we go. So I could cover it up, and then I'm just looking at these 4. Now, you can use your hand. You don't have to do these boxes or anything like that. But gives you the idea of it really helps you focus on the angles that are being asked about. Using transversal B, what are the pair of same side interior angles? So B is where I'm focused on this time. Interior angles are these 4 in here. Same side interior. Let's see, I'm going to be focused on the ones that are on the same side of the transversal. So 12 and 13 are a same side pair. And 11 and 14 are a same side pair. Okay, not only ask for one, so you just would need to give me 12 and 13 or 11 and 14. All right, either way works. And last slide, using transversal C, what are a pair of alternate interior angles? So again, narrowing things down, starting with C, and our intersection points here are here and here. Well, these are our 2 boundary lines. So interior would be in here, 2, 3, 9, and 12. 2 is an alternate interior pair with 12. And then the other alternate interior pair would be 9. Again, remember, you got to go to the other side of the transversal, non-adjacent, so other intersection. 9 and 3 would be our other alternate interior angle pair.